Okay, let's focus on the question 8. The reason for I didn't do too much on question 7 is pretty much same as question 6, but the question 8 is a little bit different. So we have more content here. First, let's open the house sales data. Give you some time to open that. Okay, so the question is asking for the sales price, right? We want to target a sales price of the lot cost and type of home without any interaction term, right? So we want two inputs. One is lot cost, another one is type of home. Come back to data here. So the issue here is the type is not numerical data. For regression here, we can only use the numerical data, but here we have a categorical data or text data here. And let's make a filter on the type. We will see there are only two types here. One is single family, another one is townhouse. So we have to create a dummy variable. What is dummy variable? Which for each column we have 0 and 1. 0 means not, 1 means yes or true, right? So here we have single family, yes or not, townhouse, yes or not, right? You can pick any one, it's the same. And the issue here is we only have two options here. If you choose the single family is 1, we don't have to put townhouse at 0 here. So with two options, we only need one column, right? So the number of columns, dummy variable columns you need is the number of options minus 1, right? You lose 1 degree of freedom here. So here, let's choose the townhouse as the column here. So if 1 means it's a townhouse, 0 means it's not townhouse. So that's an easy way to do that. Equal to the townhouse, the type, what is equal to the column name, right? Column name is called townhouse. And the column name won't change, so we put the absolute reference here. When we drag it down, we don't want this reference down, but we want type change, right? So if you put that, it's true, right? If we drag it down, it will say true, false, right? So this would be a way. But the problem is here, true or false, still not a number. What we need to do is we add parentheses around the true, around the formula and multiply by 1. Okay, now with that, so true times 1 equal to 1. False times 1 equal to 0. So you can see that. Then we can apply for every cell here. So this is the easier way to do the dummy variable. You can do if, but if is not the best, not the easiest way to do that. This is the easiest way. I'll show you this. The one, right? It's equal to townhouse. The type equal to townhouse. Or you can type townhouse here if you don't want to cell, and with parentheses times 1. Okay. So now we get two variables here. We don't want interaction between these two columns, so we just leave them separate and target as sales price. Let's create a data analysis regression model here. So the target will be the sales price. Control Shift down, and the X range would be the lost and townhouse. Right. If you choose to use single family, it's the same. You just change the name of the column E here. Output range. Okay. So this is the model. We find everything is below 0.05. It's a good model here. This good model here, and the aspect is 65%. 65%, which means that the change of the selling price right, can be explained by the lot cost and townhouse. 35% of the change of the selling price can be explained by the change of lot cost and the change of the townhouse. Okay, that's for the question 1 here. Question A here, sorry. The B is determine if an interaction between these two variables. So if we have interaction between the two variables, if we want to check that, what we need to do is we use we just multiply these two columns. So let's say interaction, which is equal to the cost multiplied by 1. Okay. Click. Now we have if townhouse. This means if it's townhouse, whether the price matter, right? If it's not townhouse, that the price doesn't matter. So let's create a regression model here. Change the x. We have extra column here. Use the interaction. Output range. Here. Okay, let's look at this model, right? So this model has a better adjusted R-square and a better R-square. Let's also check the p-value here. The p-value problem is once we add in the interaction, now the townhouse becomes to not significant here. So we should remove townhouse if we use the interaction. So that will increase the performance of the model again. So let's do the data analysis. So this time we have to change the position for the townhouse because we want to put the lot cost and interaction together. So do this way. Analysis, regression. Okay, change the x. Actually, here, change the x. Okay, change the output. Okay, this is a new model. I can now we can see that everyone is within the 0.5, right? So this model, so we can check the R-square is 66%. The original one without interaction is only 65, and adjust the R-square is 64 for the old one and 65 for the new one. So both of this performance increase. So this model is the best. So that tells you sometimes you need to check whether there's interaction between the inputs here. That may give you some bad idea, which means whether we check the townhouse price matter, right? That the price for townhouse important is very important, right? And other than that, the price for the single family is not as that important when we check at the townhouse. Okay, so this is the last question, and before we stop here, so I want to show a formula here which is called trend, which is commonly tested before. So trend is another way to do the regression. So it will ask the known y's, which is your all the y's, all the dependent variables. For here is the selling price. Control Shift down. Okay. Use normally for the range we usually put the absolute reference here. And no x. No x is what we know. If it's this one only for the numerical data here. So we want list 2, right? List 2. Control Shift down. Add. Use F4 to add absolute reference here. And the new x. New x would be list 2 numbers. Only list 2, right? So the no. Let's finish that first. No, I will explain. this is comma here. So what this do is it will train a model, right? Learn from the entire data set, right? And predict these two as new numbers, right? Predicts these two as new numbers. Actually, if you want to predict new values, you need to do this, right? So we have a new cost and a new inter, right? For example, let's say these two numbers, we change the reference to here. And if we put pick a number here, 10,000, another 10,000. Right, it will give you a predicted selling price. Okay, this is the predicted price. So the no x, no y is the actual, all the values for the actual y's, and the no x are the no numbers for the independent variables, and the new axis, right, which is the thing you want to predict, right? So that's the way. But if you want to predict the current data to see what are the errors, you will do this way, right? So this will predict each of these price based on the information we have. I can see the residuals is the difference between this one and the actual price. That's the residuals. Okay, that's the residuals here. So this is the residuals. Okay, this is another way to calculate the regression. Okay, this is the question 10. Question 10.